Welcome you all for the session of robotics, module 3, session 2. Subject mechatronics for a 7th semester, VTU mechanical engineering. Yes. Well, this chapter, particular robotics chapter, which including various operators which is required to operate the robotics, as well as this introduction, background, and advanced actuators which is used in this robots, and pneumatic actuators, what is industrial robot and different part of a robot, and controllers which is used in a robot, and drive and arm and end effector sensor, which is all the common devices which is used as a functional requirement of a robot. Yes, as of this, the outline of this particular model or a chapter is very first introduction. What is robotics and what is the background of that robotics? Means the history and the introduction is known as the part 1. And advanced actuators. What are all the actuators which is used to control the robots? Means the end effectors, that is all used in the particular robot manufacturing and robotic uses. And pneumatic actuators, we know that pneumatic actuators are the actuators which is based on the operation which is operated through pneumatic pressures. Okay. And industrial robotics, what is industrial robots and different parts of a robot controller, and then drives, arms, and end effectors, and then sensors and functional requirement of a robots. Okay. well the robots are the devices which is handle the materials, or it can be used in a very intricate manufacturing process for just like welding, spray painting. Likewise, means this is all the devices which reduces the human effort. So it has a significant to reduce the man force and increase the productivity of the any product. Means whenever we are atomizing the whole plant through these robots, it has a efficient plant. Means accuracy of the product will be increased through that particular robots. And we have several types of robots that includes humanoid robots, and um, normal articulature, and normal configuration robots. Okay. In a transducer unit, a tran actually the transducer was defined as the device that convert the one form of energy to another form of energy. Therefore, by the definition, an actuator can be specific type of a transducer. Means we have the electrical signal from the processor, so that the electrical signal has been converted into useful work. So the purpose of transducer just like this. And whenever we require to actuate the system, we are using some motors, and just like different devices of mechanical actuators. Actually, the motor is a one such actuator. A motor is convert the electrical energy into mechanical energy. Therefore, a motor is a both an actuator and transducer. We know that. And basic concept of actuators: an actuator is a something that actuates or moves something. Means the actuators are the end effectors. Means that operate something so that it achieve the required targets. And more specifically, an actuator is a device that convert the input energy into motion of a mechanical energy. Means which is required for essential service, just like pick and place robot. Likewise, there should be a several type of operation. So it's more specifically, it's an actuator. What's a device that converts the input energy? Means that convert the input signals into the motion of a device. So that the conversion of electrical energy into mechanical energy. The input energy of a actuator can be a manual, either it's a pneumatic or hydraulic, and it's sometimes it's also thermal also, and sometimes it's a electrical. Means if we having some manual operation, means we have operated the devices through lever and jogs just like that. It has the example of manual operation. If you coming to that pneumatic and hydraulic, the piston and valves are the example of hydraulic and pneumatic. If you coming to the thermal actuators, that is bimetallic switches and levers, that's are all the example of thermal actuators. If you coming to electrical actuator, motor and resonators, they're all the example of electrical actuators. If you come to advanced actuator and pneumatic actuators, means whenever we are using different kinds of operate actuators, so that which has actuated through that actuators, means generally first thing is mechanical actuator. In mechanical actuator, normally a rotary motion is converted into linear motion to perform the operation. Such an actuator is normally involve gear, rails, pulleys, chains, spring, etc. To operate, the most common example in a main engine, pneumatic actuator for changing the roller position or the camshaft for reversing. It's an example of mechanical actuator. Means it was the definition of a mechanical actuator. If you come to an hydraulic actuator, unlike the air, the liquid cannot be a compressed, we know that, and hence hydraulic generate the higher energy than the other any other system, means which is operated at high pressure range, and all system is involve high load and operated by hydraulic actuators, in which the oil pressure is applied on mechanical actuator to give the output in the form of rotary or linear motion. The basic example is the steering gear of a ship is a best example of a hydraulic actuator, in which hydraulic pressure is issued to move the rubber actuators. Likewise, there is a different kinds of actuators which is involved for robots. Third one is electrical actuator. In it is an one of the cleanest and readily available form of actuator system, as it does not involve oil, as there is no need of compressed air, and hence extra machinery is required. Hence electrical energy is always available on the ship, means the overall generation of electrical energy that has been converted into useful work. The electrical energy is used to actuate the mechanical system using magnetic field, that is EMF. For basic example of electrical motor operated valve and magnetic valve operate actuator or solenoidal valve. Solenoidal valve. In solenoidal valve, the electrical signal which will magnetize the upper portion of the valve, which will then attract the valve seat and open the system. When the electrical supply is removed, the valve get shut by the spring action. Likewise, these are all the very important application of a electrical actuators. So we need to understand another type of actuator is hybrid actuator. Generally, hybrid actuators are the combination of these three: mechanical, hydraulic, and electrical. And sometimes it's control the mechanical part of the system. Common example of thermo hydraulic electronic actuators, which is used to operate the hot water system whenever the hot water liquid is used along with the electronic acting systems. So it controls the wall, means it's all the very combination of mechanical, hydraulic, and electrical and electronics. Likewise, there is a hybrid system which is acted through. And next concept is the industrial robot. An industrial robot is a general purpose programmable machine, and it possesses some anthropomorphic characteristics just like human characteristic that resemble that human physical structure. The robots also respond to the sensory signal in a manner that the similar to the humans. Anthropomorphic characteristics such as mechanical arms are used for various industry tasks. Sensory perspective devices such as sensor allows the robot to communicate and interact with the other machine and to take a simple decisions. Means whenever the robots are very intricate, means that are operated in such an environment, so it has to take some decision based on the temperature sensor, and some of the sensor has to be activated so that it it has to operated in such a way that it won't deviate the targets. Means achievable targets has to be should not be deviated, so it has to be take care while that robots are to be an industrial purposes. Robots are good to substitute the human beings in hazardous such uncomfortable works or work environment. Means a robot can perform its work cycle with a consistency and repeatability which is difficult for human being to attain over long period of a time, and continuous working is very tedious for a human beings. Such a environment we have to go with this kind of industrial robots. Robots can be reprogrammed, and then when the production run of the current task is completed, a robot can be reprogrammed and equipped with the new necessary tooling. So means the if you change the end effectors, we can achieve the another kind of a process. So this is what the tooling of a performance, and altogether it is known as a different form of a task. And robot can be connected to computer system, and the robotic system nowadays robot can be controlled with the wireless control technologies. This has enhanced the productivity and efficiency of a automation industry. Means overall in industrial purpose, the robots are used is very efficiently to increase the productivity of the product as well as the communication. Means the line communication of that production has to be improvised through this palletizing and pick and place. Likewise, there is a different kinds of purpose to use the industrial robot. And then what are all the general and commercial technologies advantage of a uh, robots? Means these are all generally really talking regarding that robots are very substitutable of human being where the hazardous and uncomfortable working environment. Likewise, I already told that this kind of an opportunity has to be utilized through an industry to improvise their own productivity of a product. Okay. And then if you ask to be use and different parts of a robotic controller, the manipulator of an industrial robot consists of a series of joints and links. Means it has a several types of a series of joints. Means it has a joints, uh, means the arms which is consisting of just like human being, we having from hand, means the elbow joints and shoulder joint and arm joint and finger joints. Just like that, the manipulator or an industrial robot which is consisting of several joint series of joints and links. And robot anatomy deals with the study of different joints and links, and other aspects of a manipulator is physical cons- constructions. Means we need to understand what is the robotic anatomy and what is the skeleton of that robot which working on. Means how it look like, how it is impersonation of the man, and just like that, if the fingers of a robot actuate like human beings only. And we need to study how that freedom of degree of freedom which is provided to that end effector, how that physical structure is constituted for creation of that robot, that has to be understand. Means the robotic joint provides the relative motion between the two links of a robot. Each joint axis provides a Cartesian degree of a freedom. That is means Cartesian means there is an 90 degree linear motions, means if the actuator which is operated in a x or y direction only, either both the direction must be operated. In most of the cases only 1 degree of freedom is associated with in one single joint, means that is what the required perception to increase the productivity of a device. Means if you operate that robot for particular joints to be at multi degree of freedom, it is not possible. Why? Because we need to have that degree of freedom to be precise. So if you provide a multi degree of freedom to single joint or a single place, so it has very complex, that is therefore the robot is complexity can be classified according to the degree of freedom only. And each joint is connected to two links, an input link and that is output link, means that should be within that two only. Means sometimes the action has to be taken place through several links, but sometimes it has two links only, one input link, another one output link. The joint provides the controlled relative motion between the input link and the output link. The robotic links is rigid component of a robot manufacture. Means we have to be the rigid link, but it must be a resistant link. It has to undergo some deformation, so it has some capabilities of flexibility for handling such a material. The most of the robots are mounted on upon a stationary base, such as floor or some bases has to be provided. From that base, the joint link numbering scheme may be recognized as shown in the next slide. Uh, you just see this is what the floor, and this is what the base, and this is known as link number 1, this is known link number 2, sorry, this is link number 1, this is link number 2. Actually this is 1 2 3, and these three links are joined through two different joints, that is joint number 1 and joint number 2. Means if it use it as a cylindrical coordination system, means this link which is rotated um, about this point, center point, and this is what the rotation of the degree of freedom of a rotation to have that degree of freedom as a circular. And with respect to this link number 1 and link number 2, that is also an rotary motion, and this is what the link 2 which is operated in this direction, or clockwise or anti-clockwise, means this is which can be swinged like this from this hinge point. Means this were all the manipulator joint purpose. And you just see the robot base and common base, its connection to the first joint are termed as a link 0. The first joint in the sequence is joint 1. Link 0 is the input link for a joint 1, while the output link from the joint 1 is link 1, which leads to joint 2. Thus the link 1 is simultaneously the output link for a joint 1 and the input link for a joint 2. This joint links or numbering scheme is further followed for the joint and links in a robotic system. Okay, and these are all known as the different types of a links. Means this is what the linear joint. Linear joint means the input link as the output link must be actuated through with respect to input link in linearly. Means this is only the motion which is possible for this link, means this is reciprocating motion only possible in x direction, or positive x direction or negative x direction in this joints are operated through this kind of a operations only. If you coming to orthogonal joint, it has a different, means the perpendicularity is very important. Means this is what the input link and this is what the output link. throughout this body, means the output link which is attached to the input link, there has to be traveled around this overall span in this x, positive x or negative x direction. It is possible in if it is a square, means it has only one single degree of freedom. If it is round rod, means it has some rotary motion in this y direction also sometimes. Okay, this is what known as the orthogonal joint. If you coming to rotational joint, from this hinge point, this is what the rotary center for this output link, and the with respect to input link, the output link is winged about this point, means this is the rotation center point for this output link. Coming to the twist joint, as of this input link, this output link has a twisting motion about this axis, same axis, so that it has some degree of freedom of one x-axis rotation. So its joint is known as twisting joints. Coming to revolving joint, as of this input link, with respect to this input link, the output link is revolved about x-axis only. The swinging portion is which is referred by y-axis, means about x-axis only this output link is rotated. As of this, the basics of links are classified. Linear joint, that is L, it can be known as L joint. Orthogonal joint is known as type of U joint. Rotational joint, type of R joint. Twisting joint, type of T joint. And revolving joint is known as V joint, or from V, that is V in revolving joint. Okay, thank you for watching this session.